Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 12 students and the topic of discussion is determinants. In this video we will be focusing on NCERT solutions for exercise number 3, which is dealing with minors and cofactors. The first problem, we need to find minors and cofactors of the elements of the following determinants. So let us proceed with this. So what are minors? Minus for this first element is written as M11. So we write like this, equal to. So how do we proceed? 2 minus 4 0 3, we write the matrix or determinant again. Since this is first row first column dealing with the element 2, we remove this and write the balance one as 3. Now the cofactors denoted by A11. What is the difference between cofactor and the minus is that now additional sign will be coming. So sign minus 1, 1 plus 1, 1 plus 1, M11. So this is 2, this will be even, so this will be positive, so this will remain 3. Similarly, we can do for M12. 2 minus 4 0 3, so it corresponds to this element, so we'll remove this column and this row, so we'll get 0. So A12 will be minus 1, 1 plus 2, M12 equal to 0. What is 1 plus 2 here? 1 plus 1, we are adding the ith row and jth column like this. Here also we are adding ith row and jth column here. Similarly, M21 will be minus 4 and A21 will be minus 1, 2 plus 1, minus 4. So this will be negative, negative of negative is plus 4. M22 equal to 2 minus 4, 0 minus 3. So this element we are talking, so we'll cut these two, we'll get 2, and cofactor of the second element will be minus 1, 2 power 2, 2 is 2 itself. So we have calculated all the minors, these are the minors and these are the cofactors of the matrix. Now this is a 3 by 3 matrix, so we want to compute the minors and the cofactors. So let's do one by one. So M11 will be 5 minus 1, 1, 2. So we can multiply 10 equal to 10 minus 1 minus minus 1, which is equal to 11. A11 equal to minus 1, 1 plus 1, 11 equal to 11 itself. Similarly, M12, so we remove this column and this row, so we are left with 3 minus 1, 0 and 2. So 3 into 2, 6 plus 0 is equal to 6. A12 equal to minus 1, 1 plus 2, 6 equal to 6. M13. Let us write M13. So that is this element. So we'll remove this row and this column. So we are left with 3501. So this is 3 into 1, which is 3. This will be 0. So A13 will be equal to minus 1 power 1 plus 3 into M13, which is 3. So this will be 3. M21. So this will be this element. So we'll skip this row and this column. So we are left with 0412. 0412. So 2 into 0 is 0, minus 1 into 4 is minus 4. A21 equal to minus 1 power 2 plus 1 minus 4 will be equal to 4. M22 will be this element. So we'll skip this column and this row and this column. So we are left with the elements 1, 4, 0, 2. So 1 into 2 will be 2. Minus 0 into 4 is 0. A22 will be minus 1 power 2 plus 2 into 2 will be equal to 2. Let us find the balance minus and cofactors. M23 will be equal to 1001, which is equal to 1. A23 will be equal to minus 1 power 2 plus 3. 1 equal to minus 1. M31 equal to 0, 4, 5 minus 1. Minus 1 into 0 is 0. Minus 5 into 4 is minus 20. A31 will be equal to minus 20. M32 equal to 143 minus 1, which is equal to 1 into minus 1 is minus 1. 3 into 4 minus 12 minus 13. A32 will be equal to minus 1. 3 plus 2 minus 13. This will be minus. So minus minus 13 will be 13. Similarly, M33 minus of the third element is 1035. So 5 into 1 is 5. Minus 3 into 0 is 0. So A33 will be equal to minus 1. 3 plus 3 into 5 will be equal to 5. So we have computed minus and the cofactors for each of the elements of this matrix. Using cofactors and elements of second row, evaluate the determinant this given by this. So we need to find using the second row. So this is the second row. So using this we need to compute delta. Delta is sum of the products of the elements and the corresponding cofactor. So it will be sum of the product. So we have to do product. We'll start with 2, which is the elements A21. So A21 into A21. This is the element and this is the cofactor, plus A22 A22 plus A23 A23. So we have to compute first. A21 is known, A21 is 2, A22 is 0, A23 is 1. So we need to compute A21. A21 is minus 1 power 2 plus 1. So we are taking this matrix. We ignore this and this, left with ignoring this and this. We are left with 3823. 3823. So 3 into 3 will be 9 minus 9 minus 16. So this will be equal to 7. 3 3s are 9. 9 minus 16 minus 7 equal to 7. A22 is 0 because 0 into the minus 1 minus 1 power 2 plus 2 5 8 1 3. So this will be how much? This is positive. 3 5s are 15 minus 8 equal to 7. A23 minus 1 power 2 plus 3 5 3. So we have to ignore this and this and this, sorry. So we are left with 5 5 3 1 2. 5 3 1 2. I repeat again, this is the element we are looking for, so we ignore this and this, so we are left with 5 3 1 2. That's what we have written here. And this is negative. 5 2s are 10 minus 3, which is equal to minus 7. So now we can get delta or the determinant. So A21 is 2, 2 into 7 plus A22 is 0. So 0 into 7 will be 0 plus A23 is 1. 1 into minus 7. So this is 14 minus 7. So which is 7. This is the value of determinant. In this problem, we need to find cofactors of elements of third column. Using the cofactors of the elements of the third column, we need to evaluate the determinant. So we have to use these elements, cofactors. So how do we get? We know that the value of determinant will be this element, which is A13 into cofactor A13 plus A23. This is A23 into A23 plus A33 A33. So these are, capital A's are the cofactors and the small one, small a is the element. So we know A13 is YZ, A23 is ZX, A33 is XY. So we can get A13. This is A13. We remove this row and this column. So we are left with 1y, 1z, 1y, 1z, which is equal to minus 1. Here we will have term 1 plus 3 also, z minus y, which is equal to z minus y. Similarly, you can compute A23. There will be some minus 1 also, minus 1 power 2 plus 3. So that will be 1x, 1z, 1x, 1z. So this will be equal to x minus z. Similarly, A33 will be minus 1, 3 plus 3. So this element means this row will go and this column will go. So we will be left with 1x, 1y, 1x, 1y. So this will be y minus x. So delta will be, we substitute this in this equation, equation 1. So let us substitute that yz, delta equal to yz, z minus y plus zx, x minus z plus xy, y minus x. On simplification we get delta as x minus y, y minus z, z minus x. Friends, with this we conclude this video. Now there is another problem left. If delta is this matrix where Aij is cofactor of Aij and the value of delta is we have seen. If we take any column or row, the delta is given by the sum of the products of elements and their respective cofactors. So that's what given here. Now which one is true? That is to be understood. Let us see first A11, then A31. This is not correct. First this itself is wrong. So this full is wrong. A11, A11. This is correct. Now if you are taking second element A12, it cannot be A21. It has to be A12. So this is also not correct. A21, A11, again it is not correct. So full expression is not correct. Let us see this. Yes, A11, capital A11, A21, A21, A31, A31. This is the correct expression. Friends, with this we conclude this video. Please like and subscribe my channel so that in future more videos can be released to you instantaneously. Thank you very much, friends.